In this video, we show various string graphs in Catecon. In particular, the origin of the icon for string graphs is given. Let's get morphing. String graphs, or sometimes referred to as Kelly-McLean graphs, see nLab, are used for coherence in closed categories. In Catecon, they visually indicate what some morphisms are doing, and the C++ code generator uses them for determining variables. Our first examples are just some simple factor morphisms. Select them and hit the G key, or the string graph icon. Essentially, a string tracks the identity in a morphism. Next, we see the two distinct morphisms from A cross A to A cross A, the identity and the twist. In Catecon, the twist is indicated by a factor morphism where the factors are reversed as indicated by the 1 followed by 0. For the product and coproduct, we have the graphs for the delta and fold morphisms. In Catecon, Hob objects are indicated by square brackets in the typical manner. The left side indicates the domain and right side the codomain, and the bracket expression the space of all such morphisms matching said domain and codomain. By using the lambda action, or currying, the domains of the delta and fold are moved to the domain side of the codomain's Hob. These pointed objects just then pick out the morphisms out of that space. When strings touch, they should inherit the same color. Here we see the identity on A cross B versus the product of the identity, and dually. Distribution has its own interesting form with built-in deltas. Next up are the identities on Hobs and products. Currying those two give us the evaluation map E on the left and the D on the right. Connections are as expected. Now curry the Hob A to B to the right side of the evaluation to get our next morphism. Take the Hob of that latter morphism with the identity on C. Note that the left hand of the Hob is what is known as contravariant, meaning the direction of the arrow is apparently reversed as we see here. Here is another evaluation, and we move the left-hand factor over to the codomain. We have enough to do some composing, so here we have the result. Let's just look at the resulting composite. And there's the string graph icon with the evident angled element. Setting B, C, and D to the closed categories unit yields a morphism from A triple dual to A triple dual that may not be the identity. Now let's tackle the Arens Multiplications. These are morphisms from what normally would be A double dual tensor B double dual to A tensor B double dual. Now here I'm in the cat category and not some category of vector spaces, but we'll make do in the construction using the same means as for a classical Arens multiplication. And here are their graphs. That's a bit mysterious, so let's try to get a more detailed look at all the currying that gives us these two morphisms and their very, very long names. And there we have it. Let's take a look at the left side first. Essentially use the D to add the parameter Hob of A cross B to I to the original codomain. This technique gives us enough to start doing evaluations. Do it again on the right side by adding A. In the next stage, use the morphism Hob A cross B to I to Hob A to Hob B to I. By isolating the A, we can now form the evaluation to reveal the Hob B to I in the next stage. That is evidently another evaluation, and another to get the final shape. The right-hand side is similar, but has the roles of A and B interchanged. In the final graph, there is no choice for linking A's and B's, so you see the strings get crossed in this setup stage. In a later stage, we uncross when the order of isolation of the variables is chosen. Quod erat demonstratum. String graphs in Catecon.